The following podcast is sponsored by Structure Tech.
Welcome, everyone. You're listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich, alongside Tessa Murray and Reuben Saltzman. As always, your three-legged stool coming to you from the Northland, talking all things houses, home inspections, and anything else that's rattling around in our brain. Well, today we're just a two-legged stool because Tessa is unavailable, so she's not on the show. But it's Reuben and I, and our special guest today is Brock Verville, and he's a home inspector here in Minnesota. He's also a fire inspector for the City of Albertville, and he's also a paid firefighter for the City of Albertville. And we're going to dig into some fire safety topics today, and we're really excited to have Brock on the show. Thanks, Brock, for joining us.
We're going to get into a fire safety conversation today and talk a little bit about some of the safety features that we see in houses, why they're there. Brock, I'm going to throw it to you right away because when we were prepping for the call, you had a good saying that fire codes are based in what? Why don't you go ahead and tell everybody this lovely but gory saying?
Yeah. So, first day of Fire Inspector 1 certification course, my instructor said, "Why do we have codes?" And his response to us was, "Codes are written in blood." Now, what do they mean by that? That means codes aren't just derived by somebody saying, "Hey, you know what? Let's restrict the way that people can build," or "let's make it harder for somebody to put together this and that." The purpose of codes is to correct something that caused injury or death in the past. So a lot of these things that oftentimes don't make a lot of sense to us really are driven out of tragedies or avoidable things that had occurred. And what we're trying to do is prevent reoccurrence in the future.
And he's on the show today because he's got a really unique perspective, being both a home inspector and a firefighter, looking at it from both sides. So I think he's got a really good appreciation for how sometimes people might roll their eyes at some of this stuff. I mean, you're doing a home inspection and you're talking about some of the safety stuff. And, a lot of times people go, yeah, you're a home inspector, you're paranoid. But it's like, no, this really does matter. So what is some of the biggest stuff that you come across during home inspections when it comes to fire safety that it's a big deal for you?
Well, obviously go with the number one on the back of everybody's mind, because it is both the most important aspect of fire safety as well as the most annoying for most people. And that's fire alarms, smoke alarms. And smoke alarms, there's a lot of information about them. And there's a lot of information that people just really don't truly have about smoke alarms. Now, what is the biggest eye roll? Obviously, it's coming down to changing batteries. Most people aren't aware of the fact that, look, you're not supposed to change the batteries when it starts to beep. You're not supposed to change the batteries once a year. The saying is, you change your clocks, change your batteries. And the reason for that isn't necessarily that the batteries are being drawn down that quickly. The reason is the number one reason for fire death is non-operable or non-existing smoke alarms. And so it's that important that you just don't want to take the chance that a battery is faulty or a battery has lost power and the smoke alarm isn't going to operate properly. So as annoying as it is, change your batteries that frequently. Now, the industry has remedied that a bit with these 10-year sealed lithium ion batteries, where now you don't have to go and change them. And that is a really fantastic ad because it makes it harder for people to disable their smoke alarms. It's a more intentional act. They can't really forget to give it the power that it needs. And then the last thing is when the 10-year ones beep at you, they're beeping at you for one very important reason. And that's that the smoke alarm is now expired. And that hits a really important point as well. People are oftentimes not aware that these smoke alarms, they don't last forever. They expire 10 years. That's all you get from date of manufacture, 10 years. And, talk about one of the things I call out on home inspections very frequently is expired smoke alarms. Oftentimes I'll even get response from some agents where they say, well, did you test them? Do they work? Well, what are you testing when you press the button? You're testing the audible alarm. You're not testing the sensors.
Yeah.
And so what you're encountering is you get this false sense of security. As I push the button, it beeped. Great, it works. The reality is though, once you exceed 10 years of life, the failure rate of a smoke detector can exceed 30%. Now let's put that in perspective. A recall would be issued if a smoke alarm on line of manufacturing had a failure rate in the neighborhood of 1.5%. 30% is the observed failure rate of smoke alarms older than 10 years. It's that important to change them out regularly.
And I'll bet that's past 10 years, and I'll bet it continues to get worse and worse as every year goes by. I mean, we see a lot of smoke alarms that are 20, 25, 30 years old. I mean, what we like to say is once it's turned yellow, it's surely more than 10 years old. Like you don't even need to take it down. That's just how you know.
Yeah, absolutely. Yeah. When I see them yellow, I don't even check the dates. I'm just like, that it's way too old.
That's good.
I've got a smoke alarm in my second floor that's been there since the day we moved in. And it's probably been there at least 10 to 15 years prior to us moving in. And I want to claim this as a relic. I want to see how far it goes before it just gives up the ghost. But we have 4 other smoke alarms within like 3 feet of this thing. So I'm not concerned about it. It's hardwired and it looks funny and it's going to stay there until, I don't know, it quits making noise.
And it's not being lazy.
That's exactly right.
All right.
We carry on.
I got to ask you this, and I will open myself up to criticism and condemnation from you. Be honest now. You talk about replacing your batteries when you change your clocks twice a year. And I'll admit, I do not do that. I have a home where all of my smoke alarms are hardwired and interconnected. Yep. And I've got they're all new batteries. They're new smoke alarms. I put in all new alarms when I moved in. And I've just got this idea in my head that, well, because they're already powered, it's like, it's going to be fine. And I honestly don't do it until they start chirping at me. How bad is that? Be honest.
Well, I mean, you're right that, most people don't. And I would say myself, I'm guilty of that. It's just not top of mind, not to mention too, if you're talking about 9-volt batteries, they're not cheap. They're not easy to find. It's probably the only thing that really truly runs on a 9-volt anymore these days. But the reality is this. So the purpose of the battery is battery backup, right? So could it be a non-issue? Sure. If you had a fire ignition while you had power supply to your house, sure, then it's going to draw power off the electrical system and you're not going to have an issue. But what happens if it's a lightning strike to the house and you've lost power? Now that backup is a matter of life and death. And this is where the numbers start to get really kind of frightening. You go back 40, 50 years, safe time to evacuate a house fire was 17 minutes. If you were out of your house in 17 minutes, you had a very good chance at surviving that structure fire. Now, that timeline is shrunk down to 3 to 4 minutes.
Whew.
That's it.
Wow.
That's wild.
And so you lose time, and that becomes a big problem.
Why is that? I know it's partly to do with materials, but is it also to do with the way houses are built now? You've got these framing members that oftentimes are webbed and they're wide open and there's a lot of oxygen and there's a lot of air and that can move through that. Does that cause a fire to move much more rapidly than in a house that was built with far less air chases, so to speak, in there?
Yeah, absolutely. So it's kind of a multifaceted thing. So one, you're right. Building materials have changed. Fundamentally, we've moved to lightweight construction materials. The reason isn't that they're better in all regards. The reason why we've moved to lightweight construction materials is the solid wood is basically cost prohibitive at this point. So all these lightweight construction materials kind of harbor one fatal flaw. Either one, you're talking about composite type materials in which it's bits of woods that is compressed and glued together, in which that glue is petroleum based, which means it's solid fuel. It's an analogy. It's not actually gasoline, but think of it as solidified gasoline. So you have a higher fuel load. The second thing is, when you get into trusses, trusses are small runs of lumber that are held together with gusset plates. These gusset plates, when a fire achieves 1200 degrees temperature, the gusset plates begin to warp. Steel begins to warp at about 1200 degrees. structure fire inside of a contained room, when it reaches flash over, you're talking 1800 degrees. So you're easily reaching the point in which gusset plates will warp. Well, when they warp and those teeth pull out of the wood, all the little tiny bits fall apart.
Sure.
And so what you really encounter is, one, you have heavier fuel loads. You have a higher propensity for structural collapse. So if you're talking legacy builds, old long runs of solid lumber, in a lot of basically testing of structural loads under fire impingement, you're talking about structural collapse occurring, I should say, at around an hour and a half of fire impingement. In new construction materials, you're finding structural collapse in as little as 7.5 minutes. And that's unprotected floors. And so again, we have codes like firewalls, fire breaks, and things like that are meant to protect those structural members so that you don't have that. Well, so that's one end.
There's a big one that came out in 2017 for all new construction. And I know that was driven by fire departments. It was protecting our floor structure. Anytime you got engineered lumber, you can't just leave it exposed anymore. It's like, that's why we see drywall on basements on just about every new build now, which
absolutely,
it's a little bit obnoxious as a home inspector. I can't see any of it. And it feels like it'd be obnoxious for somebody who wants to finish their basement someday. It's like when you want to run everything, you got to take it all down, and then you can run all of your pipes and your wires and ducts and then put it all back up. But it's like, it's not there to make your basement look nice.
No, in fact, I actually had a large national builder, and I'm sure you've probably encountered this on a few inspections where they really kind of fight you on new construction. They're like, why are you even looking at it, kind of thing, or you can't go there. I'm not going to let you pop the attic, that kind of stuff. And so we are kind of going around, what I'm going to be inspecting. And the guy said, you know what, let me ask you a question. Why did they make me put drywall in the crawl space of this structure? Why am I finishing a crawl space area? And he had no idea. And the reality is yes, it's a fire break. So unprotected, those floors can collapse in 7.5 minutes. You add 1/2-inch drywall, it's now 20 additional minutes because gypsum is non-combustible. Eventually it will spall and fall apart, but it will give you 20 minutes additional life on any unprotected floor.
Brock, where do most fires originate now in 2022? If you could give me the top 3.
The number one is kitchen. And it's funny because if you look at some of the fire codes, like there's a room in our house that is built basically like a fire containment box, and that's the garage. Garage has firewall requirements up and down and left and right. And it's basically saying, hey, you're guaranteed to have a fire start in the garage. And the reality is that most fires actually start in the kitchen. Most of them are going to be that. Obviously, smoking ranks right up there still. That's never going to go away. In fact, the fire fatalities as a whole, when you look at fire fatalities of themselves, it's smoking leads that year after year after year. And that's really what it comes down to. What we also see is electrical fires. Electrical fires are probably number 3 in there. But what's really interesting when you look at firewall requirements inside of garages and stuff, I have been on a number of structure fires where, again, the reality with this lightweight, newer construction is that when we get on scene, it's not uncommon for the building to be what we call fully involved. So fire has already vented itself outside. There's nothing stopping it from progressing. It's what we call a fuel limited fire, which means that thing's going to burn until it runs out of fuel if we don't go in there and interrupt. And I guess maybe I should rewind slightly and just give you guys kind of a little fundamental of fire dynamics. So I'll refer to things in what we now term the fire tetrahedron. So several years ago, we used to call it the fire triangle, saying what is required for self-sustaining fire to occur. And it used to be the fire triangle where it was you need heat, you need fuel, and you need oxygen. And now we've added a fourth, which is you need a sustained chemical chain reaction for that fire to occur. And in order to stop fire, you have to remove one of those. And then fire it's not going to perpetuate. So you had mentioned it earlier, Bill, where you said, hey, these long, these open chases, are we seeing more oxygen delivered to the fire? And the answer to that is absolutely we do. So back 40, 50, 60 years ago, most structure fires were ventilation limited. So if a fire started and Nobody changed the conditions. They didn't leave a door open or break a window or something like that. The fire would run out of oxygen and it would actually go into decay phase. And sometimes it would actually put itself out. Now, with all the open concepts, we don't have ventilation limited fires anymore. We have fuel limited fires, which means they're gonna go. So getting back to my story is we find that these now fuel limited fires, when we get on scene, they're ripping. So the days of fire departments making entry into the front door and putting a fire out inside of a room, some older construction, you can still have that. But by and large, you really aren't finding that's the kind of fire attack that we're into. Now it's transitional or defensive, which means transitional is we're hitting it from outside, we're knocking the flames down enough. Now we're making entry and we're putting the rest of the fire out and going into overhaul where we're picking out the last little bits of hot spots. Or it's defensive, which means we're hitting it from outside. We're trying to protect neighbor houses from starting on fire. And that's about as far as we can go. But I have been on numerous structure fires where the fire burns through the entire house. Basically, there's not a whole lot left of the house, and there's a garage. And you open up the garage door, and inside the garage, it looks like nothing had happened inside of there. The firewall, which was designed to stop fire from going from garage to house, did it in reverse, and it stopped the structure from transferring into the garage. And it's really impressive on how well that drywall can actually work at stopping the progression of that fire.
So it sounds like we need to start doing these in kitchens, is what I'm hearing.
Well, again, with open concept, yeah, it'd be great, but nobody's going to go for that because
but then it won't be open.
Exactly. And then everybody's going to hate that tight claustrophobic feel of the kitchen, and nobody would do it.
I say it totally tongue in cheek, but
yeah, absolutely. But we had an attempt at a fire code that would have done that, and that was the requirement for sprinklers.
Yeah.
Sprinkler systems are remarkably effective. I have yet in my fire career to be on scene to a structure fire where there was sprinklers there and the fire was still going. It will stop it at incipient phase and it'll keep it from progressing, or it'll slow it down to the point where we're basically just wetting down a small little fire. But they are massively effective.
Yeah. That was in our code for like 3 months, I think. And didn't take long for the Builders Association to really fight that and get rid of it.
Yeah.
I got to tell you, right around that time, it was when I was still blogging for the Star Tribune. I did an April Fool's blog, first and last one I ever did. I said there's a new requirement in Minnesota where all existing homes are going to need to be retrofit with sprinkler systems. Not only that, in lieu of guardrails on the sides of open stairways, you can actually use ball pits now, like they have at Chuck E. Cheese. And I had all these like little tells, but it made me I learned this day that people don't read, they just read headlines.
Yep.
And people read the headline and the state started getting flooded with angry phone calls, and they contacted me like at 7:30 in the morning, and they were not very happy with me. And I'm like, I will fix it right away. So that was my first and last attempt at April Fool's humor.
Yeah, people are definitely sensitive to that.
Yep. Brock, a couple things. You said 7.5 minutes to fully engulfed if there isn't any limitation on the ventilation, like there isn't fire stops from one floor to another. That doesn't give you, as a firefighting crew, a lot of time to get there, get unloaded, set the trucks up, and start spraying water. Second question, do most fires start when people are awake or when they're asleep?
Oh, I think that I don't know if I would really characterize either. It's so random. It seems like my mandatory months where I have to respond overnight, they happen overnight. And then the rest of the time they happen during the day, but it really is kind of hit and miss. We always say it's, when we haven't had a structure fire in a while, all of a sudden get ready and they're going to come in flurries, and we'll sometimes go 6, 7, 8 months without a structure fire and then get 3 in the span of 2 weeks. So it's really a random thing, but your response to a structure fire is very different nighttime or daytime. Part of the now asks from, or recommendations, I should say, from the state fire marshal office is smoke detectors inside and outside sleeping areas. Now we're talking about that obviously as a code. Now, why did they add that into code because the recommendation is you sleep with your bedroom doors closed. Now, why would we want people to sleep with their bedroom doors closed? And having toddlers myself, that oftentimes is very hard to do because you start shutting bedroom doors and they don't like it. But the reality is that what you're trying to do is you're trying to restrict fire's movement. So a fire got started and let's say your egress was blocked. Having a bedroom door closed can provide a cocoon of survivability for a period of time. And when a fire department arrives on scene, what is paramount, one of the first things that's going to happen is the first arriving truck, the person in the front right seat is your officer on the scene. Their job number one is they're going to do a 360 around the house. They're going to walk around the house and they're going to look at smoke. They're going to look at, can they determine where the seat of the fire is? And they're going to give the arriving crews and their own crew, they're going to tell them, this is what we need to do to effectively fight this fire. What they're also looking for is people that are trapped, yelling out of windows, things like that. So they want bedroom doors closed so that, hey, if you can't get out of your bedroom, you keep that door closed. And what you're going to do is, again, you're going to limit ventilation. That fire is not going to be able to easily achieve oxygen, so it will go elsewhere where oxygen is more readily available, which may give you enough time for the fire department to arrive, see you banging and yelling on a window, which again, you don't want to open that window and necessarily start feeding oxygen into the structure. You want to yell and bang on the window as loud as you can. And as soon as an officer sees somebody doing that, our job number one is get a ladder, get up there, get that person out. So always life preservation. We always say in a fire department, we're going to risk a lot to save a lot. Human life, we will risk a lot to save a human life. We will risk very little to save very little. We are not sending firefighters inside to save your couch or $90,000 Shelby Mustang that's in the garage. That's not what we're going to risk people's lives for. But if we see somebody that is alive inside of a structure, that's job number one, is to get them out. So it's things like that. So with your bedroom doors closed, smoke alarms, especially if they're interconnected, you're going to be alerted. You're going to wake up. If you can't make it out, you're in a safe spot, at least initially.
Now, you talk about windows, and I just want to hear how you report as a home inspector when you come across a house, say 1950s house, and none of the windows there meet today's standards for egress or emergency escape and rescue openings, as we now call it in the building code. What is your comment to clients when you come across that?
So again, there's a reality in home inspecting of, we could walk in there and say, oh my gosh, this is the most dangerous house you're ever going to be in. This is not, meeting modern egress requirements. And what's going to happen is, somebody's going to maybe get freaked out. Maybe they don't buy a house. Maybe that's the right house for them. I feel like our job is to more present material fact. So I report it as, hey, this is not meeting egress requirements modern. I explain that, look, you're grandfathered, so it's not going to be required. But what we look at in fire inspecting is something very important, which is intent of code. So what is the intent of the code? So when you have a minimum opening space on an egress window, what's the intent of that code? Well, a larger adult human being can make egress out of that window. When we talk about well requirements of having, permanently installed well ladders, it's so that somebody can climb out. When we're talking about sill height, it's so that a small child doesn't have a difficult time climbing out of that window. But you can meet the intent of the code even if the window itself doesn't meet that egress requirement. So let's use the sill height. You get into Minneapolis and there's a lot of houses that the sill height is above that minimum 44 inches. So what's the intent of the code? It's to make it easily climbable. So what I tell people is, hey, be aware that if you're going to have a small child in this room, you maybe want to have a desk, a bed, something right up here against this window so that they're not climbing that full 45, 46 inches. They can climb onto something and then out the window, and the intent of the code is met. Now, the best example I can give off this intent of code is the code that says that commercial structures over certain square footage have to be fully sprinkled. Well, we have a very large commercial structure in St. Paul that is not fully sprinkled. That's Excel Energy Center. It's not fully sprinkled. Now, why? Well, over the bowl where the ice is, if you had sprinklers and there was a fire at ice level, that water would never reach that fire. It would evaporate before it ever got anywhere near it. So the sprinklers would be ineffective. So the intent of the code on sprinklers is to buy time for people to evacuate the structure. So what they've installed instead is a smoke removal system that they can actually ventilate smoke out of the arena, which gives enough safe time for people to evacuate, because the smoke would be ultimately the most dangerous thing if there was a fire at ice level. And so did they meet the code? No, they met the intent of the code, and therefore it's allowed.
Sure.
I have a question as it pertains to commercial buildings. A lot of them are steel, drywall, other things that don't really burn. And I imagine the Xcel Energy Center, what could really burn in there? I guess a lot of things, but it seems like a fire wouldn't spend a lot of time in there. It would die itself up pretty quickly. Is that fair to say, or not really?
Yes and no. So what you're talking about construction type is type 1 construction is your concrete. The type you're talking about with drywall and steel is like your storefronts kind of thing. That's type 3 construction. So you're right. The structure itself doesn't burn readily. A lot of that stuff is non-combustible. And the idea behind it is you don't want structural collapse, but your interior fire load is very different. So if you had a type 1 construction, which is non-combustible construction material, but it was full of wood pallets, oh, that thing's going to get ripping. And that's going to be a dangerous fire to fight, because the fuel load inside the building would actually probably classify as what we term a special hazard. So when you're into Xcel Energy Center, something like that, well, you have plastic seats, you have all kinds of things that can burn inside of a non-combustible overall structure. And what you'd really run into is the toxicity of the fires that come off of those type of materials. So when we're talking about fires being so dangerous nowadays and type of smoke that are in fires, a modern fire, there's somewhere in the neighborhood of like 8,000 known carcinogens inside of structure fires these days. In fact, now rapidly, so it always used to be that the number one cause of firefighter death nationwide was heart attacks, and cancer is really quickly passing it. Cancer is the number one concern we have, because we're exposed to so many chemicals that leach into our skin that we're far more likely to develop terminal cancer than the general public. And so if you're thinking about a fire like inside of Xcel Energy Center, and you're thinking about people evacuating, what you're more worried about is, the phosgene gas, these hydrogen cyanides, these things that are given off from the fire that could cause people to die, even if the fire was nowhere near them. And so the idea there is your interior fire load still provides a very dangerous environment. That's why that smoke removal is what they use to provide a tenable atmosphere for people to get out.
As somebody who's in this field, is there a reasonable amount of time you can work as a firefighter where you're not significantly putting yourself at risk?
Depends on the fire. It really does. So at the end of the day, what you're ultimately looking at is, there's limitations to our gear. And the biggest thing is we need to be on air. Our air bottles are for the most part rated in the 20 to 30 minute range. The reality is when you're working as a firefighter, you're probably 10, 12 minutes of air before, not out of air, but at the point at which you're not going to make a dangerous or a situation that's already dangerous more dangerous by running out of air and making your co-firefighters come in and rescue you. And so when you start getting low on air, so you're really in and out kind of thing. If we were talking commercial structure, again, collapse would be the biggest concern I would have. And so that's going to be really read on what is the fire condition, what is the building doing, that kind of things, and what are we saving? So that's ultimately what it comes down to. In a residential home fire, there's a guy that was on the department with us for years, and he ended up taking a job up in Bemidji. And I talked to him like a year after he went on to that fire department, and he said, it's incredible how many room and contents fires we put out, where you're actually making entry and putting out a single room. Now, why? The construction up there was different. It's older construction. You get into our area where it's a lot of new construction, and the fires are really, by and large, fully involved when we're getting there, which is why you go out to suburbs and you see people always comment on how much space is between houses. That's defensible space. That's a fire code. The idea there is if you pack houses in as tightly as they did back in the day in Minneapolis, St. Paul, fire is going to jump from one structure to the next, to the next, to the next. And it's going to be a big problem when you have a single structure fire.
That's interesting. I wonder, there's a lot of teardowns and rebuilds in the city. And I wonder how they're addressing that because the setbacks aren't changing, are they?
No, they're not. So a lot of it comes into grandfather provisioning. So if they're able to maintain whatever the city has as their grandfather provisioning, they can achieve it that way. But cities might also, so that they're not losing that buildable space, they may throw up requirements. So the bigger concern that I have a lot of times is less about the knockdown rebuilds, because then the city can really kind of dictate, hey, this is how we want you to construct it. A lot of times they're actually going to put in like requirements for like non-combustible siding. You go to these old neighborhoods, what do you see a lot of? Stucco, brick, the old asbestos tile type siding. Why? It's non-combustible, protects the house from starting if their neighbor did. And then you have a guy that rips that siding off and throws vinyl on, and his house is 4.5 feet from the next house. That's going to be a problem if one structure starts. And so that's kind of what you run into is the city can require certain things. They can say, hey, if we're going to let you build here and we're not going to make you adhere to these side yard setbacks, then you're going to build it this way.
How much space do you need between two structures before like 1200 degrees, let's just say? Is that is that an average fire heat, or is it much hotter than that?
Inside, interior, it can be, absolutely. Outside, it's going to be less because obviously the heat's going to go up, it's going to dissipate. You're going to get more radiant heat that's going to affect nearby structures. Now, that being said, so every municipality can set their own setbacks. That is city by city basis. But I'll tell you that, out here, we have a lot of space, and it's pretty common that you'll see melted siding. Like the neighbor house didn't start, but the vinyl siding was definitely affected by it. So it's a concern. But that being a concern, that's also one of the things as a fire department we pay attention to. If we have a structure on fire and it's fully involved, well, our focus can somewhat not shift off of that structure. Obviously, we're doing what we can to put that out, but we will also probably pull attack lines to cool neighbor houses so that we're not raising the risk that those houses will ignite.
Sure. Yeah, I've got a buddy who lives in Otsego, and one of his neighbor's houses started on fire. And he sent me pictures of the neighboring house. I mean, this is a newer development. They had big setbacks between the properties, but still all the vinyl siding was gone. I mean, it all melted off the house just from the heat from the one house. Crazy how much it affects it.
And the source of the fire in a situation like that, a brand new house? Occupant behavior?
Don't know.
You can oftentimes find that information with the state fire marshal if it's determined. And that's when you get into fire investigation, is kind of the joke of, every fire is undetermined until they can pinpoint an actual cause. So you always hear, a fire investigator being interviewed in some sort of high profile fire, and they'll say, what's the cause? And they'll say it's undetermined. Undetermined doesn't mean arson. It doesn't mean anything other than we just can't pinpoint it yet. Some of these structures burn so completely that there really is no way to determine. And so it will remain undetermined. But then there are some where they can kind of go back. And it's a really fascinating subject, fire investigation, of how you can tell. So you get into like smoke alarms. Did the smoke alarms go off? You can actually tell in fire investigation, if the smoke alarms are preserved, you can actually tell whether or not it was sounding when the fire was going on. And the way you tell that is at the vents for the audible alarm, you'll actually see this kind of starburst pattern of soot depositing if it was sounding from the vibration of the alarm sounding. Whereas if it didn't, you don't get that pattern. And so they can tell if a smoke alarm has been sounding or not. And actually, that's a great tangent into the discussion of types of smoke detectors, because it's a really contentious debate. There's a lot of information out there, and there's a lot of information that can really kind of heavily go in the direction of scary and feel like it's a dangerous oversimplification. So there's two types of smoke detectors that exist. There's photoelectric and there's ionization. An ionization detector detects the ionized particles that come off of the actual flux, the actual plasma of the flame. A photoelectric detector is detecting that visible black smoke from a smoldering fire. Now, there's a lot of data out there that says, well, hey, photoelectrics are far and away better than ionization. And yes, they are, depending on the lens you're looking at it. So ionization detectors detect quick flaming fires. Photoelectrics detect smoldering fires. They're two different types of fires. Both can occur in a house. So a misnomer is, hey, we just don't see fast flaming fires anymore. Not true. They can still happen. A ionization detector will detect a quick flaming fire on average 52 seconds faster than a photoelectric will. But a photoelectric will detect a smoldering fire on average 26 minutes faster than an ionization. So you look at that and you're like, well, I'll take 26 minutes over 52 seconds. But the correct answer is you don't have to give up time for either. It's important for you to have both present in the house. We shouldn't be going away from ionization detectors. We should require both to be present. Ionization detectors to save you 52 seconds. Let's go back to that evacuation discussion. What was the safe time to evacuate a house fire in a modern structure? 3 to 4 minutes.
Yeah.
Let's go to the scary number, 3 minutes. You lose 52 seconds with only photoelectric detectors. You just lost a third of your evacuation time. You don't want to do that. Now, on the flip end, there's a lot of the discussion of, well, ionization detectors just never even went off. Well, why didn't they go off? If it's a smoldering fire, and let's say it's 26 minutes before they're going to detect the ionized particle off of the plasma, well, probably that structure is burned to the ground in that amount of time. So yeah, it never went off. It didn't get a chance to. And there's studies out there where they replicated this and they said, look, these ionization detectors don't even work. Well, they do, just not in that type of smoke environment. And so having both is really key, and give yourself the maximum amount of time to get out.
Yeah, that actually makes sense. And ionization alarms are not expensive. They're just a few dollars and you can leave them laying around. I mean, it's not a burdensome thing. Do most fires start because of occupant behavior, or is it because of a failure of some sort of device or electrical, or how, is there any statistics behind that?
By and large, you're going to be talking about occupant behavior. You're going to be talking about people just not following. And it doesn't necessarily mean the homeowner. Sometimes it's contractors as well, where they'll put something together. And I mean, Reuben, you may even have stories on this too of, I have so many times that I've had older electricians call me and say, you called a double lug out in the panel. Well, I've been doing that my entire career and I've never had an issue. Well, okay. Yeah, you might not have had an issue. One, it doesn't meet code, so end of discussion there. But all you need is one, and it's not worth the risk. Yeah. Right. So you have this situation where things can be either assembled or, just done in a way that it is not 100% as safe as it could be. And then you have occupant behavior, where you have things like people smoking, people plugging space heaters into power strips, things like that. People using extension cords as permanent wiring, where the voltage drop across that run is going to generate heat. And you have stuff like that. So occupant behavior or human behavior, I think, is going to be far and away your biggest thing.
No, you talk about electrical. I got to ask, what's your take on arc fault circuit interrupters?
They are very useful. So what the arc faults will do is, they're going to sense that arc, which anytime you're going to have a fire, typically you're talking about arcing in the electrical system, things like that. So it's going to basically catch it at its earliest phase, and it's going to cut the power to the circuit, which is invaluable when you're talking about, hey, let's stop a fire before it ever begins. Great. Now, at the end of the day, you get into mechanical things, and if they're not, there's potentials for failures in them. If people don't exercise the breakers, if they're not sure that the arc faults work, I mean, there's maintenance to anything, and it just adds another aspect of that. I've talked to some firefighters that said, hey, we've had all these fires in which the arc faults never tripped. Granted, there was definitely a first generation of arc faults and things have steadily improved. I think some of those Cutler Hammer, the CH type breakers, the earliest generation of arc faults are around 2000, 2001. They were like massively sensitive, ran really hot. Like, you put a thermal camera on them and they're in the neighborhood of like 70-ish degrees hotter than a standard breaker, which an arc fault will run hotter than a standard breaker, but they were definitely beyond that. And what did Cutler Hammer end up doing? They ended up redesigning the breaker, and they've got the newer version, which is doesn't have the issues. So, but yeah, as a whole, I mean, again, the reason why it's there is it's prevented fires for sure.
Sure.
Do you see secondary fires happening from like melted electricity, or electrical lines or something like that, or a gas line that has been damaged in a primary fire causing a bigger issue later on, or even during a fire? Do you get like secondary explosions and things like that when continuously running gas, all of a sudden a line will melt? Or
Yep. So we can definitely run into that. So controlling utilities is one of our earliest jobs on a structure fire. As long as it's safe to reach the gas line, we'll shut the gas off and we'll lock it out so that somebody can't turn it on. So yeah, there is definitely controlling utilities, things like that. It's just one of the hazards that we have to pay attention to. It's interesting that you bring up gas lines because I mean, it's so ad nauseum. I have to hit it with CSST and the bonding requirements for it. I've seen fires that didn't get fully going, but there was scorched siding and a smell of natural gas after a lightning strike. And it was from unbonded CSST where it arced out of the line. And so there's things where, yeah, these requirements, again, really kind of come into play to avoid a lot of this stuff. And back to the human behavior, if not done properly, you can create issues. And so, but yeah, secondary fires for sure, you can have that. We've had a number of garage fires where people were storing propane tanks and things like that. And man, when those things blevy, they definitely get your attention.
do those things blow out when they get super hot?
They do. Yeah, they'll blevy. So it's liquefied petroleum. So heat it, it'll eventually boil. When liquids boil, you're talking about massive expansion ratios. So expansion of that generally in the 1700 to 1 volume increase. So now you've hyperpressurized this vessel. And the point at which that steel fails from fire impingement, it's going to rupture, and all that gas that's now hyperpressurized is going to expand to that 1700 to 1 volume increase. And what ends up happening is as soon as it exits the container, well, there's immediately a flame that ignites it as it expands to 1700 to 1, and you get a very energetic explosion. Now, fortunately, with those smaller propane tanks is limited amount of fuel, limited amount of explosion. If we were talking about large LP tanks, they have pressure relief valves that they're trying to prevent that from occurring. But if one of those things actually blevied, that would be a really dangerous event, really dangerous. It's funniest thing, you want a really impressive training to go watch a fire department, come out our way and watch us when we do our LP tank training, where we'll actually simulate an LP where the pressure relief valve has triggered. And it's like a 60-foot flame spewing out of a tank. And you set your water streams to a fog, which basically is just this big fan of water. Think of it like spray on your hose. And we overlap them and walk in, and the fog actually pushes the flame back to the point at which we can expose the tank, and the person in the middle reaches in and shuts the gas off. And then you retreat back with it in fog.
I would very much like to see that.
It's really cool. It's really cool. The next time I'll send you an email. The next time we do it, more than welcome to come out and watch it.
Sounds like being on the set of Mythbusters.
Kind of, yeah. And the reality is my guess is if that was an actual scenario, we wouldn't go anywhere near the tank, because again, what are we saving? Now, we would do it, sure, if there were people trapped, but if people had evacuated, yeah, we're not walking up to a hyper pressurized LP tank. We're going to basically cool the tank. And if it ruptures, we're far enough away that we're not going to get hit.
These things don't rupture and blow apart in two pieces. They'll just, a seam or something will develop, and then a large quantity of the gas will escape and things will settle back down. Is that usually the case?
No, well, if they truly blevy, there can be shrapnel. There are some cases where some fire departments lost firefighters because of it, where LP tanks have blevied and they were hit. And there's one where like there's photos of it, and like half the tank was A, it was flattened, but B, it was like several hundred yards from where the LP tank was, and it flew a long distance. So it's a particular hazard for our firefighters for sure.
This word, you've used it several times. Can you spell it?
Blevy?
Yeah.
It's BLEVE. So it's an acronym. It stands for boiling, liquid, expanding, vapor, explosion. So
Gotcha.
You boil the liquid, the vapor expands. If it exits the contained structure, it explodes. And so,
Gotcha.
and you want to see some of the best, yes, Mythbuster-ish videos, just Google Levy, and they're frightening.
Nice.
Well, I think we should begin to put a close on this. But Brock, I want to ask, more fires start in a house or in a garage?
In a house.
Okay. What percentage of the time do garages go versus a house going?
It's a tougher thing to answer in terms of percentage. One, I don't have an actual percentage on it, but number two, it more has to do with fuel load. You know, a detached garage is probably more likely to go up than an unattached garage because people are working in detached garages sometimes differently. And so it's more on what are you storing in it? Are you storing fuel? Let's say somebody has a wood shop in a detached garage. Well, that's going to be more of a hazard because you've got sawdust, which is highly, highly flammable. Potentially they're varnishing. And if you have polyunsaturated oils and you store the rags on top of one another, they'll spontaneously combust. And so you can have oily rag fires that there was no ignition point. They actually spontaneously combusted from the oils that were on it. And so it's all over the board as to terms of what type of hazard you're ultimately looking at. Now, at the end of the day, it really comes down to the biggest thing that you can do is not necessarily focus on you obviously do want to focus on how fires start, but there are fires that'll start that you really didn't have any ability to prevent. An electrical fire, something like that, where you just couldn't determine it, those freak type of fires. And the number one thing that homeowners should just be aware of is all those things that just get annoying to hear in terms of fire safety. Make sure you have smoke alarms on every level of the house, inside and outside sleeping areas. Have carbon monoxide outside sleeping areas within 10 feet. And notice, I'm not saying bedrooms, I'm saying sleeping areas. If you have a basement where somebody's sleeping, it should be treated like it's a bedroom in terms of code requirement. So sleeping areas is the way that now the fire marshal terms it. Have an evacuation plan. Make sure that everybody knows if smoke alarms go off, where to go, how to get out. If their primary egress is blocked, what is their secondary form of egress? Know that, look, with the timeline shrunk down as much as it is, as much as people don't like to inconvenience fire departments, with 3 to 4 minutes being your evacuation, don't lose time trying to determine whether or not it's a false alarm on your smoke alarm. Leave the house, let the fire department come. I promise you, there is not a firefighter alive that does not fully enjoy riding lights and sirens, fully geared up, even if it's for nothing. We enjoy it every time. I become a 6-year-old me every time I do it. And so just rely on that fire department. You know, let us come, we'll figure it out. And if it's not anything, we'll tell you it's not anything. And then we'll give you the peace of mind. But just treat it really, really seriously because, you know, a lot of these deaths that occur are preventable. They really, truly are. And it just takes the information being out there. One of the biggest things I had said to you, Reuben, at the onset of the discussion of having this be a topic was, you know, we're in a really unique position as home inspectors that we get to be inside these houses on these walkthroughs with these brand new homeowners. And this really should be a discussion point in these home inspections where we can say, hey, this is how fire may behave in your house. This is what you can do to be safe. These are the things to kind of keep in the back of your mind, because we have an audience that, one, it's pertinent, and two, we're able to hit basically everybody after everybody's going to be buying and selling houses. If everybody's having this discussion, we're going to be able to get this information to everybody, and it may save lives. And you know what? The fire inspectors always say they'll save more lives as a fire inspector than they would as a firefighter, but nobody will ever know that you did it.
Thank you, Brock. I think we'll wrap on that. And thanks for all the information. That voice was Brock Verville, home inspector, Brock, fire inspector, Brock. And Brock, you are on the department in Albertville, correct?
Yes. Yep.
Okay. Awesome. Well, that's great information. I think every house needs a number. They need their number, the time you have to get out of that particular dwelling, maybe stamp it on the wall somewhere. Thank you, everyone. You've been listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich alongside Tessa Murray and Reuben Saltzman. Thank you for listening. We'll catch you next time.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.